Okay, now we'll look at the animation of developing a El Nino. So here we have the normal conditions. Let's develop an El Nino. What should happen? So you have the trade winds, you have the upwelling, cold tongue, warm pool, rain, the nice Walker cell. As I said, without trying to understand what triggers or starts the El Nino, let's just start to look at the various feedback processes that begin to occur. Okay, so develop an El Nino. Here we are. The trade winds are blowing. Walker cell is going on, but somehow the trade winds got weaker, and you often also have anomalous winds from the west called a westerly wind bursts because they are on a weather time scale of 3 to 10 days, and they are of a certain strength, like 8.5 meter per second or so. Or it could happen from weakening trade winds, reducing upwelling, warming the temperature, increasing the pressure, or warming the temperatures, reducing the pressure gradient, and so on. So, nonetheless, you have now this anomalous Walker cell where the pressure is anomalously high in the west, so there is subsidence. Pressure is anomalously low in the east compared to the normal conditions. Warm water has kind of spread all along the tropics. There are many details here. Remember, it's called El Nino because the waters arrive around Christmas time. The warm waters here on the coast of Peru and Chile arrive around the Christmas time. So during Christmas time, the sun is to the south, so you can see this asymmetry here that the warmest waters are more to the south on this side, but it's not as accurately drawn as you would think. But nonetheless, the convection has moved. The rising motion is anomalously high over here. You again are hitting the tropopause, and there is a westward upper branch anomalously sinking over the West Pacific. Okay, these are real things. These are serious. These have serious consequences, right? It's good to get rain and snow in the mountains and these places which need the rain, but it can also be too much rain, and you end up with mudslides where people die, and the upwelling is reduced. The fish die, the seabirds die, and so on. On the west, you have droughts, wildfires in Indonesian forests. There is a human component, as I said before, which means as soon as there is a forecast of an El Nino, so if in July of a particular year, climate forecasters announce that it's going to be an El Nino, then people may intentionally start to set fires and blame it on El Nino. Why do they set fires? To clear the forest for growing palm trees, for palm oil, or for development. Okay? So you have to be aware that nowadays human actions are being used to exploit forecasts in a good way and in a very bad way. What can you do? Okay, so there are dust storms in Melbourne. There are some classic photos of dust storms during El Nino years, and the fun is that there is some data that says it gets so warm during a so dry during an El Nino that Australians drink more beer. Okay, so there you go. That's another impact. So we will see later on what the teleconnections are, but I already mentioned several. Rainfall and winter storms over parts of the west coast of the US, but also happens in the southeast, in Texas, in Florida, and so on. There is also some changes in the northeast, in New England states, and so on, Chile, etc. I mentioned Brazil, Nordeste region, I mentioned East Africa, I mentioned Indian monsoon. Those are all teleconnections which happen during El Nino and La Nina. Not exactly opposite to each other, but nonetheless they happen. So look at the El Nino development carefully, and the scale shows 1 to 12. Typically, this whole system moves at a pace. Remember, ocean moves slowly, so even though atmosphere can move fast, it's the ocean heat content that's controlling the whole situation. So the life cycle of an El Nino is anywhere between 6 months to 18 months by the time it starts in terms of, let's say, weakening trade winds or eastward movement of the West Pacific warm pool, to exhausting all the warm water and then normal conditions beginning to return. So trade winds eventually will begin to get stronger again, upwelling will begin to get stronger again, the entire system will begin to push the waters back towards the west again, get heated, warm pool gets established again, and you go back to normal conditions. So deviation from the normal conditions into a La Nina, termination of the La Nina back into either El Nino. Many El Ninos end up going into a La Nina. Many El Ninos become abnormally cold after they are finished, but many times it goes back to normal conditions. There are various reasons why more La Ninas happen after an El Nino, but hardly any El Nino happens after a La Nina, and so on. But those are the details that we won't go into. Okay, so just understand these basic feedbacks: Bjerknes feedbacks, Walker cell, cold tongue, warm pool, thermocline slopes, etc. Great.